This video is gonna to talk about a very important theory that Kowowski in 2006 used to decide whether the fund manager is skilled or not. And what we're gonna say is this equation 2.10. The whole process, the whole bootstrap process that Kowowski used is based on this theorem. And it means that the empirical p-value of the t-statistic of the alpha is smaller than A. That means in our total B bootstrap replications, the number of the bootstrap t-statistic that is smaller than the actual t-statistic, this number is smaller than A. And if it is smaller than A, then this event is true. The probability, the conditional probability that this event is true is equal to A plus small o p1. What does it mean? So this event, when this event is true, it means that the actual t-statistic is located in our bootstrap confidence interval, that which is dependent on A. And if it is the event that it is located in the interval, the probability of this event is equal to A, then we can use we can say that we can first generate this confidence interval and say that the probability that our real t statistic located in this interval is A. Let's say if it is not equal to A, then we can still generate the confidence interval, but this confidence interval does not mean anything. If it is equal to A, then we can say that we can say with A significance level that our t statistic is 0 or not. Then if it is 0, it means that the fund manager is not skilled. If it is not in this interval, then we can say with A significant level that the fund manager is skilled. Okay, this is the explain of this equation, and it has some theoretical proof which is in this paper. But what I'm gonna to do is I will use bootstrap to show this result, to use the simulation to show this result. My simulation process is gonna to follow this paper also. In the first step, I will generate the factor returns. Remember that the factor returns is the same for each fund because it's like a mutual factor return. It's only different for different period, but it will be the same for each fund. The only difference for this fund is their epsilon it, which is other that unobserved factors, independent variables. And in real life, we will not be able to know the real epsilon it. So here, in order to test whether our theory is correct or not, we generate the epsilon it, but in real life we will never know. And based on this it, we can get the actual y, which is the 0 alpha fund return, because here we set alpha to equal to 0. And then we can calculate the t-statistics. And I do this step in my lab. So here I generate the t-statistics, and for each I to n, which is different font, I generate their epsilon, z, and then I show the result. Then for each font, I can have their own statistics for I to t n. This is the real value. And next step, I do the bootstrap, which is the process that is used in the Kowowski's paper. And it is routine, but it is kind of difficult because if we use the normal code to do that, it will be really inefficient. So here I generate the bootstrap t-statistic by using my code, which is derived t. I defined this function here. It's not that difficult, but it's really much more efficient than the normal way that we can generate the t-statistics. So here I generate the bootstrap t-statistics. And next step, we want to count the number of bootstrap t-statistics which is less than the actual t-statistics. And we also want to know whether this number is smaller than A or not. So next step, so next step, here I generate the t-statistics for each bootstrap result, which will give us a very big data set. So each row we will have 1000. That is the bootstrap replication. And for each bootstrap replication, we will have different t-statistics for different font. Since we set n equal to 500, so we will have 500 font. And then we rank it for each replication. Here we can see the result that for the first replication, we rank all the t-statistics, bootstrap t-statistics, and for the second one, we do the same thing. And eventually, we will have 1,000 column, 1,000 replications, which will give us the bootstrap ranked bootstrap t-statistics. And what we're gonna to do is, for the first ranking bootstrap in our, the actual t-statistics, we rank it, and here is the ranked actual t-statistics. We compare this result to the whole bootstrap replications for the first ranking t-statistics, and see how many numbers of these t-statistics that is smaller than the real one. And if the number is smaller than the t-statistics, then we say that this event is true. And what we're gonna to show is the probability that this event is true is equal to A. So here I rank it and I count for, I summarize for the number of the bootstrap statistics that is smaller than the real actual one, and compare it to A times B because we have total B replications. We can divide it by B to the both sides, which will give us the same result. And we will replicate this whole process for 1000 times, which is given in this paper with 1000 replications. But I will not do that in this video because my computing power is not that good, and for each bootstrap process it will take me like 10 seconds. If I do that for 1000 times, it will be a very long time, but I may do that someday with a powerful computer, but not now. What I do here is I just simply do the same thing, but it's not that correct. So what I do is for each ranked t-statistics, I calculate the number that it is lower. That I try to find that whether this event is true or not. And for the whole 500 fonts, I find that how many of this font with this event that is true, and I summarize them together and divide it by n, which will give us the similar result, but it saves us a lot of time. So here, suppose we set a equal to 0.1, then we do the result and summarize the empirical probability of this event, which is equal to 0.1320. It's approach to 0.1, which is A, but it's not totally the same. And let's try it for another A value. So for A equal to 0.05, we will get the empirical probability, which is equal to 0.06. And we can do the same thing to set A to 0.4 and we get 0.03, and we can even set it to 2 and we get 2.5, set to 3, we get 4. So the whole result shows that the probability is gonna to approach to A, but since I'm not doing that in a good way, I just doing that in a approximated way due to my poor computing power. So I think this almost showed that the result. Remember the equation that we were talking about? This probability that this event is true is approach to A, and that is why that in Kowowski, the way that he do the bootstrap makes sense. But this paper also explained under certain situation, this event may not true, and I will do that in the futures videos. Thank you.